context engineering is one of the most important skills when building agentic software. So in this video, I want to quickly go over what is context engineering, how is each type applied to building agents. Then we're going to go over everything we learned with a live case study from Anthropic. And then right at the end, I'm going to give you all the resources you need to dive in a lot deeper for yourself. So, what is context engineering? And if you already know this, skip to this point in the video. As Andrew Karpathy puts it, LLMs are like the new operating system. The LLM is like the CPU, and its context window is like the RAM. It's only got a limited amount of capacity. I'm sure you probably noticed after the first prompt of an LLM, performance significantly drops. Well, you're not crazy. There was actually a great paper on this by Microsoft and Salesforce called LLMs Get Lost in Multi-Turn Conversation. And what they noticed is, after the first prompt, performance drops by almost 40%. So this is just to say LLMs can't handle a lot of context. And there is a great article on this which breaks down context poisoning, context distraction, context confusion, content clash. But in short, bad context management means lower performance. So what context engineering is taking these instructions, knowledge, tools, and managing the LLM's context window to have the best performance. There are a ton of different ways of doing this. As you can see here, there's instruction system prompt, long-term memory, available tools, user prompts, and more. But for the next section of the video, I'm going to go over how LangChain breaks it down, because I think they've done it really well. So, what are the different types and how can we apply them to building AI agents? We define 4 types: write context, select context, compress context, and isolate context. I'm going to go over every single one with a live case study at the end. So, write context. A good example of this is long-term memory. You see sometimes with ChatGPT, it remembers stuff about you, it takes in some context, and it saves it elsewhere, so it can retrieve it later. A second example is select context. This is where it can select and retrieve other bits of context from places when it needs it. So a really good example of this is RAG. Everyone knows RAG. You just have a file with all your private information, and the agent retrieves it only when it needs it. So the next type is compressed context. This is an example where an agent might summarize something to then pass it off to another agent or human to save context. Maybe there's a big article and it needs to compress that just into the key points to save the context. As you can see from this example, a task is given to one agent and it compresses it and breaks it down into key points to give it to other agents. And the last part I'm going to go over is isolated context, where multi-agent systems work so well. You can have many different agents with isolated context between themselves where they have really defined responsibilities. So one agent might have a lot of context about how to do sales really well. Another one might have a lot of context on how to research really well. So they both have different responsibilities, so they don't actually need to share that context. So let's break down everything we've learned from those 4 types of context engineering and put it in a live case study from Anthropic. Some of you might have seen this blog from Anthropic. It's how we built our multi-agent research system. And this is such a good example of context engineering. This is a high-level architecture of how they built it. So the user might have a question like, what are all the companies in the United States working on AI agents in 2025? Make a list of at least 100 of them. For each company, include the name, the website, the product description, what they want to do, types of agents, what they build, and their vertical/industry. The lead researcher is going to begin by thinking through the approach and saving the plan to its memory, right? So it creates a big plan of how it's going to distribute things to other agents, exactly how it's going to research, and it saves that and it writes the context. And this is good because the plan is so long, it's going to be hard to keep it in that context window without lowering performance. So the second part of this is now it's going to select context. So it has its plan, it's spinning up different agents, and it's retrieving parts from its plan to give from the different sub-agents that are going to research the topic. Half of them are going to look for companies, half of them are going to look for verticals. None of them are going to need this long plan in their context because the lead agent has kind of handled that for them. And now this brings us to our third type. So now the lead researcher has spin up all these different agents. They're going to compress their findings to send back to the lead researcher so that doesn't get overwhelmed with context. The last part of this is isolate context. So as you can see here, we have citation subagents, which we haven't talked about yet. And what this agent's job to do is to citate all the sources coming in. So this is a great example of isolated context. It only needs to do that job, it specializes at that job, and it does it really well among all the other search agents and lead agent researchers. I think this was such a good example for context engineering, but if you want to go over in a little bit more depth, here are the resources that you need to know. All the system prompts, blog, and everything you need to know about that system I talked about before is right here. This blog about how long context fails is really, really useful to understand why LLMs can't handle long context. And of course, I couldn't do this without the LangChain blog on context engineering. They go over each aspect of this really in depth. And lastly, we just finished some highly relevant research at Core Protocol. We just took loads of highly specialized agents with mini models and benchmarked them against big models to show specialized agents with good context engineering outperforms just making models bigger. If you want to check out the research around this and build some multi-agent systems for yourself, all links are going to be in the description below. Goodbye.